Hello and welcome to Crazy Math Productions. Today we're looking at scientific notation, and we'll get an overview here, just the basics of the scientific notation. No products or quotients, just the basics. Okay, we want to write scientific notation, write them in scientific, write them in standard, and just how we're going to use that in general. Okay, scientific notation, there's two factors involved. The first one is going to be a number whose there's one digit, one non-zero digit in front of the decimal place. The other one's going to be some power of 10. And even though in algebra we've moved to more of a dot notation for multiplication, we do use x's for this scientific notation. For example, if you had 34 and 2/10 times 10 to the fifth power, that would not be in scientific notation. You would need to have one non-zero digit in front. So you need to move it left once and that up. We'll discuss that later. Okay, first example. So the Earth is roughly spherical in shape, volume is very large. I'm going to write this number in scientific notation. So just a little animation here. You see that as the decimal moves, the exponent goes up. Now, is that in scientific? No. There's three non-zero digits in front of the decimal, to the left of the decimal. Is that in? No. Two digits, non-zero, in front, to the left. That is a scientific notation. Now, we don't need all of these zeros since they're to the right of the decimal. So, but you notice these arrows here, this is what I'm going to use. So if you're taking notes here, which would be a good idea, I have two sets of arrows, to the left and up, and to the right and down. Everything we can use in scientific notation will be based on these two directions. I like to think of it as magnets. They either attract or they repel. But either way, you're going to have to the left and up, to the right and down, and that will be what we'll be dealing with in the scientific notation. Okay, pause and try these on your own. See how you do. See how you did. All right, this is going to be decimal place here. 1, 2, 3, 4, 5. So we'll move left, and we're going to move this up. So it's going to be 7 and 89 hundredths times 10 to the. Since we're going up, that's going to be a positive. You can think that if you're in a building, there's going to be basement levels, and of course ground zero. Then you're going to go up, so we'll go up 5 floors will be positive, so it'll be a positive 5. So it's 7 and 89 hundredths times 10 to the fifth power. Okay, number 2. Moving to the left, here's the decimal. So 1, 2, 3, 4, 5, 6, 7, 8 times. Since we went to the left, the exponent goes up. So 2 and 56 hundredths times 10 to the 8th power. And last but not least, move it to left. 1, 2, 3, 4, 5, 6. 4 and 100, oops, 124 thousandths times 10. Let's see, that's 3 6 times to the 6th. Since we moved left, that moves up, so this is a positive. All right, example 2. Now we have a very small number. So here's the decimal place. We're going to move this decimal place to the right because we want one non-zero digit in front of the decimal, that is, to the left. So let's move that. 1, 2, 3, 4, not yet, 5. If we move to the right, it's going to go down. It's going to be 5 and 6/10 times 10 to the. Now, since we've gone down 1, 2, 3, 4, 5 places, it can be 10 to the negative fifth. And that's it. You notice as we move that decimal to the right, that exponent goes down. Again, pause the video, see if you can do these. Let's see how you did. Move the decimal 1, 2, 3, 4 places to the right. If you move right, the exponent goes down. It's going to be 7 and 89 hundredths times 10 to the negative, let's see, 1, 2, 3, 4. Okay. Decimal moves right 1, 2, 3, 4, 5, 6 places. That's 2 and 3 hundredths times 10 to the negative 1, 2, 3, 4, 5, 6. Okay, and last but not least here, move it to the right 1, 2, 3 places. That's 4 and 124 thousandths times 10 to 1, 2, 3, the negative third. Okay, and you can also work backwards here. Now, in this one, we're going to think of it as we're on the 5th floor of a building. So you're in the, let's see, that's 3 floors. Oops. Let's get 5 floors here. Now, unfortunately, somebody pulls a fire alarm. So you are here, and you want to get out of the building because there's a fire. It's a terrible fire, but you get the idea. Looks like a bush. Anyway, we want to try to get out of the building. Now, to get out of the building, you've got to go down to get to ground zero here. So we're going to go down. Now, if you go down, remember, you've got 2 sets of arrows, either to the left and up, or to the right and down. And it is time for the clothes to be out of the dryer. Okay, so we're going to go down and to the right. So we're going to move the decimal 5 places to the right. So 1 and 9 tenths. 1, 2, 3, 4, 5. Fill those empty spots with zeros. So 190,000. There you go. Okay, now, in this case, you're in a very large building. Not only do we have some floors above ground, but you also have an extensive lot of libraries. We'll do this. You also have an extensive subterranean structure. So you have, for lack of a better word, little floors this way. Now let's say this is the ground zero floor. We got -1, -2, -3, -4. So you're right here. And the same thing happens. There's a fire. Let's see if I can do a better fire this time. Still looks like a bush, but anyway. There's a fire. You need to get out of the building. To get out of the building, in this case, we're still going to have to get to the ground level to get out. So what we're going to have to do, we're going to actually have to go up to get out of the building. So -4, you're in the basement. We're going to go up to get out of the building. So go up, that means the decimal is going to go to the left. Remember, left and up, the right and down. There are 2 sets of arrows. All you have to remember, those 2 sets of arrows. So 4 places, we're going to go up. That means 4 places to the left. So 1, 2, 3, 4 places. That is, now why did I put a space here? It's just once we get very, very small numbers, it's very easy to keep track of them by having a space between every 5 numbers. 1, 2, 3, 4, 5 digits, little space, 6, 7. So just 5, 6, 7. Makes it very easy to count. That's tenths, hundreds, thousandths, 10,000ths, 100,000ths, millions, 10 millions. So 4,519 10 millions. Okay, try these on your own. Let's see how you did. To the 9th power, we're going to have to move this down. That means these go to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way to process this is to say 1, 2, 3, and then 6 more zeros. So 1, 2, 3, 4, 5, 6. Again, I went 1, 2, 3 and realized 9 minus 3 is 6. I need 6 zeros to be able to finish out that pattern. So this is 1,000, million, billion, 2,354,000,000. Oh no, there's a negative here. Well, does that mean that this goes up or down differently? No, it's just a negative. So again, we're 10 to the 5th. We need to go down to get to ground 0, and also to the right. So we're going to go 1. 5 minus 1 is 4, so we need 4 more zeros. So 1, 2, 3, 4 zeros. So it's going to be negative 120,000. Okay, this time we're in the basement. To get to ground 0, we're going to have to go up. So remember the arrows go up, we also go to the left. So we're going to go 1, 2, 3, 4, 5, 6. To those with zeros. Get 1, 2, 3, 4, 5 zeros. And then 58. So tenths, 100,000ths, 10,000ths, 100,000ths, millionths, 10 millionths, 58 10 millionths. Okay, this more goes into the extension, but we can do it. What's going to happen here is we have two different sets here. We're going to express the result in scientific notation. What we're going to do, we're just going to group these together. This is all multiplication. That's multiplication. This is multiplication. This is multiplication. So what we're allowed to do is to simply move these around. Use the associative and commutative properties of multiplication to rearrange them into an easier format. So 3 times 9, and then times 10 to the negative 7th. Now, here's the interesting part. When you multiply like bases, you add the exponents. So this is really 10 to the negative 7 plus 3 power. Now, 3 times 9 is 27 times, well, negative 7 plus 3 is really just negative 4. Fight, negative wins, 4 left over. Problem is, this really isn't in scientific notation. We have a serviceable answer, but it's not the correct one. The decimal is right here. Now, to correct this, we'll need the decimal to move to the left once. Of course, if you go to the left, you must also go up with the exponent. So it's going to be 2 and 7 tenths times 10 to the, if we're on the negative 4th floor, or in the basement, 4 floors, then we go up 1 floor, we're at the negative 3rd floor, basement level 3. There you go. Okay. This has been Crazy Math Productions. Thank you so much for listening.